Hello, everyone. I hope you can hear me. There is something, no problem. Just go in the chat room and then you can ask questions if you have any problems for this webinar. So thank you for joining us today. It's another TELOPS Exosens webinar. My name is Marie Lefebvre and I am the marketing supervisor here at TELOPS Exosens. I will be your host for today's sessions. Before we get started, just a quick notes for you guys. This webinar is being recorded. A link to view or download the recording will be shared with you all registered attendees in a follow-up email after the events. Usually we will assign the email probably around next week. We also encourage your questions throughout the presentation. You have a little box on the top right of this GoToWebinar screen. If anything you hear today sparks your interest, if you like additional clarification, please feel free to submit your questions at any time using the question box on GoToWebinar. We will reserve time at the end of the session to address as many questions as possible live, and the remaining questions will be answered in writing in the follow-up email you will receive next week. So with that, we'll get started with a little poll, if I may here. If you can answer, you should see a poll. So if you can answer it, and then we will see how would you rate your knowledge of optical gas imaging. So if you can take a few seconds to vote, please. Oh, this is interesting so far. So we do have a crowd with direct experience using the technology and no direct experience, but interested in the technology. So you will learn a lot. So we will end the poll in around 5 seconds, and you will have the time to learn a little bit more about everything. Thank you guys for sharing that with us. So let me introduce our presenter. For today's webinar, we are pleased to be joined by two members of the Exosens team. They're bringing together expertise from across the globe and across the global organization. First, I'm introducing to you Joseph Gomes. He's our business development manager. He's based in Houston, Texas. He has over 2 decades of experience in the energy industry. He will present our airborne methane detection and monitoring services. He will share insights from field deployment and customer use case also today. And he is also joined by Eric Guyot, our product line manager for the oil and gas segment. He's based in France. Eric has been working in spectroscopy and infrared imaging for over 30 years, and he will present the technical portion of the webinar with a detailed presentation of our new optical gas imaging, or OGI course. So first, for a quick introduction of the Exosens group, which TELOPS is part of for now 3 years, since 2023. So let's begin with my colleague, Eric. If you want to share your presentation, Eric, it's up to you.
Let's go. So thank you, Marie, for this introduction. So I'm very pleased to present our first webinar dedicated to our technologies for the oil and gas market. This market actually is subject to numerous new regulations in terms of safety and increasingly emission controls in the context of climate change. Exosens, with its many cutting-edge technologies across a wide electromagnetic spectrums, so Exosens was born to serve this market. So let's see now what we will be talking today. So first, I think this is good then so to have the context of TELOPS and Exosens. So we'll go through a quick introduction on this. Also, the different type of product and service that we do offer now in this oil and gas market. After then, so we'll go a little bit more then in the OGI technology, the description of the products, what are main metrics, and with short conclusions. Let's get into it. So first then, so Exosens. Then historically, then Exosens, that was formerly Photonis, has focused on defense-related products, such as tubes for the night vision devices. I'm sure that you have all seen some green image on the TV. Since 2021, this group has significantly expanded its portfolio to include non-defense related products, such as industrial, scientific, and biomedical applications. The oil and gas market is one of these new activities. Exosens has experienced impressive growth across all its activities for several consecutive years, with a 22% increase in turnover between 2024 and 2025. So the operations are mainly located in Europe, with also large implementations in North America. The group is structured into 5 main divisions. So Telops belongs to the instruments divisions, along with 2 other recently acquired companies, Noxant and Phasix. It should be noted also that uncooled thermal imaging and shortwave in-gas imaging are managed by the Advanced Imaging division, with which we are collaborate too. Then so now so the Telops product and activity. So first then so Telops is based in Canada, in Quebec, and then it's been founded in 2000s. So the product line was initially developed for scientific applications with very high added values, very high performance. So this is really the DNA of Telops. And specifically, then, so Telops is the leader in hyperspectral solutions for gas remote sensing. So this is that product that you can see on the left-hand side. After then, so in the following year, then so we have been developing a full portfolio of infrared camera for scientific applications. Then talking about the applications, then so we've been addressing, and so we still continue to address a lot of different applications. So it can be so in the military R&D with ballistic combustions, infrared signature, cold spray, experimental mechanics, which is maybe one of the most popular one, and so forth. Here, so this is just a few samples. You may have already noticed that gas detection identifications and even quantifications are recurring applications for hyperspectral products. We can have also other applications that involving gas measurements, for instance, in the combustions and fire research. Now, so then, so I pass the word then so to my colleague, so Joseph Gomes, and then so to give a short introduction, then so to our product line.
Welcome, everyone. Thanks for everyone for calling in today and wanting to learn more about the technology portfolio. Exosens operates under the tagline, Reveal the Invisible, and that's exactly what we do within the oil and gas sector. So today I want to cover 3 things. First, the breadth of our oil and gas product and service portfolio. Second, the typical use cases for our camera systems with integrators and operators. And third, how our methane airborne services translates into real actionable intelligence for operators and regulatory. Everything we build starts with one question: how do we make emissions visible, measurable, and actionable? Next slide. Our portfolio spans the full detection to quantification change, and across all levels, from ground-based units to aerial and satellite systems. And I want to highlight 3 layers. First, our OGI cores. These imaging cameras visualize hydrocarbon gases such as methane and a number of additional VOCs in real time. These compact calibrated modules are designed to integrate into a host of camera platforms and are enabled detection of even the very small gas leaks with our integrator partners. We are the technology behind many of the tools that are already in the field. Second are hyperspectral cores and instruments, which move beyond just simple detection into chemical identification, critical for distinguishing methane and other VOC gases in complex industrial environments. And third, perhaps the most requested from operators in the room today, are methane airborne services. It's a fully managed end-to-end solution where we handle the integration, flight execution, and post-processing reporting with our number of strategic partners around the globe, allowing operators to choose to own the hardware or just the data. Next slide. Exosens has developed a deep expertise in infrared physics and hyperspectral sensing. Our instruments combine advanced infrared technology, detectors, specialized optic systems, and integrated data processing software. This full stack capability allows us to design instruments optimized for both ground-based monitoring and airborne methane detection. Very few organizations own this entire chain, and it means that we can optimize performance end-to-end rather than integrating components from different vendors. Our mechanical and airborne integration designs expertise allows Exosens to build instruments certified for aircraft, UAVs, and ground-based platforms, giving us flexibility no other single platform provider can match. 3 points that set us apart from other camera manufacturers or service providers is our expertise in infrared radiometry and hyperspectral sensing, advanced detector electronics and optical system design, and integrated software for detection and data processing. We don't just detect gas, we understand the physics of how infrared interacts with the atmosphere, temperature gradients, and target geometries. This matters enormously for quantification of certainty. Next slide. Let me walk you through the use cases here because they represent different points in an operator's compliance and ESG journey. LDAR ground inspection is your Method 21 replacement. Our OGI cameras let a technician walk the facility and visualize leaks in real time with sensitivity of other combustible gas detectors. Continuous emission monitors take it a step further. Permanently installed sensors provide 24/7 site level awareness, which is increasingly required under regulatory frameworks like the EPA Quad OB rule. The UAV and aerial use cases is where speed and scale intersect. We can cover hundreds of acres to hundreds of miles in a single flight, triage super emitters, and feed the data directly into an ESG reporting workflow. These aren't separate products, they're complementary layers of a single emission management strategy that we provide. Next slide. And finally, I would like to highlight our flagship managed service, Methane Airborne Services. Three things that make this generally different. First, the platform is agnostic. We integrate onto fixed wing, rotary wing, manned and unmanned platforms, which means we can work with your existing operational constraints rather than requiring you to adapt to new infrastructure. Secondly, our tiered delivery structure. Immediately post-flight, you receive data package 1 with inspection stats data provided for the entire flight. The estimated detection limit, our flight speed, flight altitude above the ground, thermal contrast, ground level air temperatures and brightness temperature, ground level wind speed, and the flight which is used to verify the quality of the inspection flight, and the detection report, companies with high resolution visible images. Data package 2 with Exosens providing process detection results, which includes 2 geotiff images for each measured scene, a broad thermal image, and a visible image, organized by segments. These images can be imported into Google Earth and will display with their correct geolocation. And finally, within 2 weeks, our package 3, which is a full detection and identification post-processing report. This is our complete package. It includes an Excel spreadsheet compiling lists of all positive detections and a KLM file for visualization in Google Earth containing the same detections within the Excel sheet. Each positive detection is accompanied by detection report, including 2 visible images, the infrared and our detection plume image, with a final list of all positive detections. This stage report means your team can start acting on findings almost immediately, not waiting weeks for a final report of all detections. And with that, we'll go to the next slide, and I'll pass it back over to my colleague Eric to go more into the details of the camera systems.
Thank you, Joe. So I'm back also. Before to go to the OGI, also let's have a look also to some other product that we do have for the oil and gas market. So this range of product actually comes from the historic Telops product line. It benefits from more than 2 decades of improvements and innovations in the field of infrared hyperspectral solutions. So it is intended for high-level integrators for specific and demanding solutions, generally involving multi-gas capabilities. So those products are available in mid-wave and long wave. So this is the mini versions, and then this is mainly designed for a ground-based platform for fixed monitoring of typical large facilities. And so you can see some example on the image here. So where this is integrated on the panel tilt along with visible camera. We have also then the brand new nano version, so that you can see here on this image here, which is mounted on the gimbal, and here so you can see it. So the image with the drone. So today this is available in long wave version, so up to 12.4 micrometers. Then also you may be stay tuned because during this year, so there will be a dedicated webinar for that kind of product for the oil and gas applications. And then also there is a last line of products. So this is the single pixel FTIR spectroscopic modules. So it comes also from a recently acquired company, AirTech, which is also located in Quebec, by the way, and that Quebec has been working with for many years. Then also based on FTIR technology, so these instruments are equipped with a single pixel detector instead of an imaging array as we have in the hyperspectral technology that we just presented in the previous slide. So this is much more compact and also far less expensive. So they are generally equipped with broadband detectors that typically range from 2 to 16 micrometers. So it allows them to address many kind of gases. So you can see, so here, so this is the product by itself. You see that it relies on a specific FTIR or a swing mirror technology. Then so you have also several types of integrations here. So this is above cars. It can be airborne also. One of the applications also, this is for the fence monitoring, stack and flare monitoring, and chemical gas analysis. So now, let's go to the optical gas imaging, and especially the modules. So this is what we do offer as far as the OGI is concerned. So this is the core module for integrators, and specifically for the integrators. So what we do present here, this is the three main standard versions for the most popular gas family in the mid-wave regions. However, so the main concept behind the product range is its customization and flexibility. And then we'll see up to your project. Then we may propose other type of version of the OGI for other type of gas. So the main version is, of course, the GasCore for the hydrocarbons, methane, ethane, and so forth, and VOCs. We also offer two other versions for CO2 and CO. Note that this module also can be adapted with two specific lens models, so that are very fast with a F number around 1.2, with a focal length of 35 and 75 millimeters. It depends on the field of view that fits the best your applications. Also, we may propose also design and propose other type of lenses. So this is entirely our design according to your needs. And so before going into the products features and specifications, let's have a quick review on the basic principle of the optical gas imaging. Let's examine a simplified model just to show that there is nothing magical here about it, and so this that it's obeys to a fundamental a physical concept. So you may refer to the basic drawing here. We have the object. To be measured. So this is a gas cloud. So it's defined by its depth, spectral absorbance, concentration in ppm, and temperature. Indeed, many gases absorb infrared light at a very specific wavelengths. And then also we have the background with its own temperature. OGI are designed to detect these wavelengths and visualize the difference between infrared radiations that comes from the background on one side and the infrared radiations from the gas cloud after it has passed through a gas cloud. If a gas is present, then it absorbs some of the infrared radiations, creating a contrast that the camera converts into a visible image. It's then paramount to have a temperature contrast between the gas cloud and its background, whatever the level of concentration. So you can have a very high level of concentration of the gas, but if there is no temperature difference, you will see nothing. Not also that here, so the atmospheric contributions are not taken into account, but also that it has a real impact also on the quality of the measurement. Not all gases have the same spectral signature, which is also an opportunity then to distinguish between them. One of the main features of an OGI camera is its specific spectral filter. And the one that you can see here, so physically, whose transmission window is set to which type of gas you need to detect. Here we present the simplified spectral absorbance in the midway for methane, carbon dioxide, and carbon monoxide that you can see here then in the midway range. Then in order to increase the signal to noise ratio, all wavelengths outside the filter are rejected and not seen by the detectors. The spectral filter is mounted in the cooled infrared detector assembly. This is what we call the IDCA. So this is the assembly here plus the cooler, and then this is what you have here inside the core. So why the filter is cold? This is really to minimize its own self-emission. Then this is the very basic outline of the GasCore that we have. Then this is designed around a cool infrared sensor with a special resolution of 320 by 256 pixels. So this is what we usually call the true VGA resolutions. So this is the standard of arraying, but we can also provide the VGA resolution of 640 by 512 pixels. In general, so the gas detection does not require a very high spatial resolution, unlike the standard thermal imaging devices that, for instance, are used for surveillance. Then you have all the boards that command, control, and process the data coming from the detector. So this is what we call the NOx engine. The temperature calibration might be also useful for secondary type missions, such like thermography measurements. So if you want to, for instance, to measure the temperature of some assets. Not also the unique ability to record the data inside the core modules. This capability can be useful, for instance, for remote sensors such as those mounted on drones. Then, so we really would like to emphasize the flexibility of the Exosens OGI concept. As our customers are integrators, then we strive to adapt as much as possible to their constraints when it's feasible. Here, for instance, so there are two main examples of the OGI with different shapes, which has been specifically designed and developed to meet customer requirements. So, for instance, so this version in the middle was designed to fit into a long tube. So the electronic cards, so it can be moved on the side, on the top, again whenever it's possible. So the version on the right, so it looks like a camera. So actually it is, and it can be also useful for some typical project, and also more likely as a first unit for an integrator. So this is much easier to handle and to connect. So this is how it looks. So now, so let's go into GasCore architecture. So this is a very simplified view. It all starts with the lens that shape the light beam according to the leads. Note that we can also propose a motorized focus if the project needs. Then you have the IDCA, so to turn the incoming infrared light into the electrical signal, so to be processed afterward. After then, so we have the basic processing for the nuke. So this is the non-uniformity corrections and the bad pixel. Then also we have the 14 bits digital stage that will take care of the advanced processing. So we'll see a couple of examples in the following slides. The data can be output directly on digital format. So either in the embedded memory of GigaVisions or Camlink. After then, so we have the 8 bits BDO stage. Then so that will process the color palettes, the reticles, the overlays, and so forth. The polarity also. Then we have the camera control interface that support either Exosens protocol or standard protocols such like GenICam or OnVIF. So we have a short summary then on the feature that comes from this architecture. So you have here, so mostly the image processing, the high sensitivity mode visualization is tab and so forth. So we'll see a couple of them in the next slides. So the GasCore, actually, so it comes from both Telops and Noxons activities. So the two companies inside our business unit. And as such, it benefits from a rich heritage from both. Noxon design and supplies a wide range of core cool modules to a broad spectrum of customer and applications, such as surveillance, OGIs, and industrial inspection. They are all based around a common, innovative, and field-proven architecture. On this side, Telops is highly recognized for its unique expertise in designing instruments and data processing for gas remote sensing. It has developed a unique algorithms for detection, identifications, and quantifications of a large panel of chemical species. The video footage show a typical scene capture with Telops hyperspectral instruments on which you can detect and identify two different types of gas at the same time. A couple of examples here of Exosens core integrations into various systems. So you can see here an example in waterproof housing. It can be ATEX as well. Here, so you have an example on a Panentil platform, then so for ground surveillance. Here, this is into an airborne platform. So this is typically so the kind of system that can be mounted on a helicopter, on a light aircraft. And at last, then so you have an example here. Then so when this is mounted on a light drone, here so a quadcopter or octocopter, whatever. Then here, so you can see on the picture also a small version that has been specifically designed for a small UAV, and so this is also this kind of camera that we have here. Then the high sensitivity mode, so the processing, so sometimes so the gas leaks are often very tiny and difficult to observe. So you can see here that you see nothing. Then so we had then so to use some specific processing then so to visualize then so the gas leaks. So you can see here so the basic command, so it can be adjusted by the integrator or by the user, and so following the nature of your scene and of your gas leaks. And then so actually then so it can balance the contribution of the gas cloud by itself and the background. Some other example of video processing that we have also, so they are in the core. So this is also the heritage of the many applications that Exosens has been through. Here, so for instance, so this is a specific algorithm. Then so when you can then so colorize then so the cold part of the scene and the hot parts of the scene. There is also this very nice one. This is what we call the ATC. It stands for atmospheric turbulence or compensations. And how then so you can see the difference. So where there is the window inside, so the image is very steady. Also that on the other part of the image, you can see the effect of the turbulence that are caused by the heat. We have also some other type of processing, such like the electronic stabilizations and the correction of the distortions. Note that all the processings might not be available at the same time. Then also for the metrics, usually then so the thermal imager and thermographic cameras are defined by their NETD, noise equivalent temperature difference, as one of their main figures of merit. For instance, it is used to compute thermal imager range for a given contrast and object size. For optical gas imaging, the NETD is not relevant as the performance. Then so what we prefer, so this is So this is the NECL, that stands for noise equivalence concentration length. NECL is the smallest gas concentration path length that can be produced by a signal equal to the noise the level of the imaging system. And you can see here, so NECL actually, so this is the product of the concentrations by the length. Here, if you can see, then so the gas cloud. Usually, then so we measure, we give it for a given contrast of 10 degrees. Not that this NECL, then so it's highly depend on the gas type. This is something that I will see also on the next slide. If we take an example, so for instance, so let's consider a GasCore in the midway. Then so with the window at 3.3 micrometers. Then so for the methane, so the typical NECL is 15 ppm meters without processing. Then so let's consider the depth of the gas cloud of 20 centimeters. Then so the minimum detectable concentrations will be 75 ppm. As previously noted, then so the NECL strongly depends on the measured type of gas. The slide shows the modulation of the NECL based on electro-optical specifications of a gas core for various type of gas. When the spectral absorbance is well inside of the spectral transmission of the filter, then the NECL figure is very low. It means that it's very good. So you can see the example here for the methane. On the opposite, we took the example of the ammonia with its spectrum, which is almost entirely out of the filter. This is what you can see here. Then so this camera is not very effective for that kind of gas. Note also that the NECL can be even better for other type of gases, such like ethane, methanol, and so forth. Also, then, so I want again to emphasize on the customization capability of this GasCore. Then, so we can go through the management of the language, the logo, the color map, reticle image, information status, temperature calibrations, and the last but not least, on the digital and video processing. We can help you also then so in proposing some new processings. And also, if you have your own processing, also we can discuss also about the integrations of your own algorithm into the GasCore. Very important also for the integrators. So this is all the tools, the engineering tools that comes actually with the GasCore. So first, then so we have then so this software, so which is implemented inside the Lux engine. So this is a web-based applications. It's compatible with many type of operating system. Very easy to use. Then so you can control, command, and also do some acquisitions. You have also some statistics tools for the ROI, the timing graphs, and so forth. It's also compatible with imaging, so which is a free-to-use software, and then so you can directly import the data so coming from the camera and to convert them so to AVI format or whatever. We also have the full ICD package with the 2D, the 3D CAD, and complete user manual with all the descriptions of the commands and so forth. So this is time to wrap up. So this OGI series then so dedicated to integrators is flexible, state-of-the-art product. We look forward to discussing your project and showing you the many capabilities of this product. So thank you for your attention. Now, so we are ready for the Q&A.
Thank you for that presentation, gentlemen. We already received a few questions. Just to tell you that if you have one question, feel free to write in the box with the question mark at the top of your screen. If we don't get your question right now, keep an eye on your inbox for our follow-up email, which will contain written responses to all questions we will have today. So Eric and Joseph, would you please begin with the first question?
Yep, I'll read it on my side. We currently operate a structured LDAR program. How can Exosens be integrated into our existing workflow to enhance coverage, prioritize high emission sources, and improve overall inspection efficiency without replacing our current LDAR efforts? Related to our aerial methane detection, this allows operators to survey infrastructure rapidly, including pipelines, facilities, and remote assets. Rather than replacing LDAR programs, it serves more like a screening layer that identifies high emission sources where you potentially have leaks. Then operators with that data can go and deploy ground crews using your existing OGI cameras or our systems to verify and repair those specific leaks, improving efficiency and reducing inspection cost. Eric, I'll pass the next one over to you, if you would like.
Yes, I have a question. How far can I detect a leak? Actually, this is always a little bit difficult to answer that kind of question. So of course, then it depends on many factors. First, of the type of lens, then the field of view. So this is the first things, but also in second, what is the what are the atmospheric conditions about the humidity and so forth? What will be the concentration of the gas, and above everything, so what is the contrast with the background? So this is quite difficult to answer that. Typically then it can vary from some tens of meters to some hundreds of meters, depending on many things. What we can do then to help on this is that then let us know then your typical use case, and what we can do on site. This is to go through simulations, and then to give you then a good idea of the result that we can have. What is the cooler lifetime? So this is also a question that happens quite often. So it depends of several things. So first, the specifications of the cooler by itself. Third, and especially for that kind of system, for that kind of module, so to be integrated. So how this is integrated? So with for instance, all the thermal management. And third, what will be the emission profile? So whether it will be used, for instance, continuously, 24/7, what type of temperature, and so forth. What we can say then, so we can try to answer then to the first part of the questions. So the cooler, so usually, so for the very standard one, is start at about 10,000 hours. So for the MTTF, we can offer some also at near 20, so 1,000 hours, and for specific version also it may go to up to 30,000. So it really depends first on the budget and on the needs. You will not need to have the same cooler lifetime, for instance, for UAV applications or for fixed monitoring.
Eric, I'll take the next question if that's all right.
Yeah.
Yep. The question is, if you're interested, we are interested in aerial methane detection campaign across our assets. What specific information, data sets, input, or coordination steps are required for our team before, during, and after the flight? The way we kind of break it down within Exosens to manage a successful aerial methane campaign, it requires 3 different phases: pre-flight preparation, flight execution, and post-flight reporting. Pre-flight, if we can obtain the assets GIS locations of the well pads, facilities, pipelines, compression stations, and processing plants, we can start identifying ideal flight coordinates to be able to fly over those assets and making sure that we hit whatever your detection threshold is assigned. Knowing if there's any high risk areas or if there's areas that you would like us to do a detailed inspection would also be useful. We work with our flight provider to then coordinate those efforts and develop a flight plan for that facility. During our flight, we work with the operators, making sure that we are hitting whatever the thermal contrast is to hit the methane detection limits that we're seeking. And we provide real-time data back to the operators of how the flights are going. And then I mentioned during the discussion how we provide our data packages to operators in 3 different tranches. The first one's probably the most impactful. It's where we identified any potentially methane release, allowing that operator to go out to the facility as soon as possible to do the repair. And we have done flights before where we identified methane releases, coordinated with the operator. They can go and inspect, repair, and we recertify that there is no additional leaks, reflying that asset within the coming days or weeks. So with that, Eric, I'll pass the next question over to you.
It looks that I have a maybe last one. So for me, so does it have a multi-gas capabilities? So the answer is that it can see several gas at the same time if the signature of those gas they fall in the same spectral window. However, you will not be able so to discriminate those gas. So for instance, if you have methane, ethane, methanol, and VOCs, you will see them all also with the same camera, but you cannot make any discriminations on that. So because the OGI, it has a single spectral window. If you want to do that, we have a solution then that relies on the hyperspectral. So this is the product that was presented in the introduction slides. This is based on FTIR, and then so you can then discriminate all the absorption bands, and then you can realize each individual absorption bands with each type of gases. And in that case, yes, you can do multi-gases.
Thank you, guys. I even have a question for me. Someone asked if this presentation will be shared by email to you. Yes, it will be shared to all of you guys. Just take a look at your email probably during next week. So thank you all for joining us today. All the questions will be answered in this email. I know we received a lot. We don't have the time to answer all of them, but they will be answered in the email. Special thank you to our presenters today for sharing the expertise and the insights. So the recording of today's session will also be available in the email. Don't hesitate to write us an email if you have any other question also, or if you want to talk to our experts, don't hesitate to ask us and we will answer you gladly. Thank you again for your time and interest. It was great to have you with us today, and we look forward to welcome you to future Exosens Teleops events, and have a great day all.